A point, one of the most fundamental objects in geometry. It has been studied since ancient times, along with lines and surfaces. Here's the surprising part. Calling a point zero dimension only happened in the 20th century. Over 2,000 years later. Why did it take so long? At the center of this story is Euler's polyhedron formula. Back in the 3rd century BC, Euclid gave this definition. A point is that which has no part, no length, no width, nothing at all. Basically the same idea as zero dimension. But Euclid never used the phrase zero dimension. He didn't even describe dimensions with numbers either. That way of thinking, describing dimensions with numbers, began in the modern era. The philosopher René Descartes, famous for analytic geometry, played a big role. With coordinates came the idea. The number of coordinates equals the dimension. A line became 1D, a surface 2D, but a point needed none, so no one called it zero dimension. Then, in the 18th century, Euler discovered something remarkable. V E+F equals 2. If you take the number of vertices, subtract the edges, then add the faces of a polyhedron, the result is 2. Always 2, no matter the shape. This shocked the mathematicians. The Euler's polyhedron formula completely changed how they looked at shapes. A shape was no longer just a solid object with sides. What mattered were the relationships among points, lines, and faces. This was the beginning of a topological way of thinking, a focus on common structures, even across different figures. In this new view, points, lines, and surfaces were called cells. Cells are the basic building blocks of each dimension. And then came a fundamental question. What's the most basic cell of all? If lines and surfaces are built from points, then what about a space made of a point? Mathematicians imagined such a space and defined it as zero dimension. A point, once thought to have no dimension, finally received the label of dimension 0. Surprising! A point is a 0D cell, a line is a 1D cell, a surface is a 2D cell. Euler's formula turned out the alternating sum of these cells, number of 0D cells, number of 1D cells, number of 2D cells. That value never changes. We now call it the Euler characteristic. More generally, for an n-dimensional shape, the Euler characteristic is defined as the alternating sum of cells, from dimension 0 up to n. For example, a 3D solid has one more cell, the entire solid itself, the 3D cell. Because of that, the Euler characteristic of a solid is 1. Euler's polyhedron formula is just a special case of this more general rule. It doesn't include the 3D cell. Here are the Euler characteristics from zero-dimensional shape to two-dimensional shape. In this process, the point, once seen as having no dimension, finally became zero-dimensional. What thoughts or questions does zero dimension bring up for you? Share them in the comments. Did you enjoy this math traveling? Please subscribe for the next trip. God bless you.